Hi everyone. So here today we are going to talk about limit functions. That is chapter 10 in your textbook. So you hear what is limit here? What is limit means here, guys? So if you have a given functions, when I say x close to c, x close, very close to c, what is c here? C here is a real numbers. Then our goal here is to get what is f of x. Your f of x close to what? Your f of x close to what? X close to c does not equal c, but it's close. How close? That is something we should really know. Is that very close or very, very close? And here, when I say x close, for example, here, if I take x close to 1, where is 1 here? Oh, 1 here, right? 1 here. And I could have close to 1 come from the left here. Come from the left. Like, for example, here you could have 0.999 here, right? 0.999, that is the number here, close. So when I see x close to 1 from the left, we call it from the left. Before 1, come from the left, means we call it left here, as coming from the left. This minus sign here, or we write minus or dash here, above here, means it's a prior one, so before 1. So it could be before 1. So you have some people say, oh, I cannot take x close to 1 from the left. Like some people say, I'm going to take 0.99. Other guys, you say, I'm going to take 0.99. Other guys, they maybe take 0.9949 or 59 and so on and so forth. Here, you can take, no problem. You can take it very, very close to 1, but keep in mind does not equal 1, and we call it here left limit. So here, instead of writing when x close to c, f of x close to what, we could write this notation here as the following: lim here stand for limit, and limit x close to c for f of x close to what. So here when I say equal to what is not equal, but it's this word limit lim means when x close to c, there is arrow here close to c, your f of x close to whatever I have here, question mark, close to this sum. So when x close to c, your f of x close to what? So that is our goal for today, how to figure out. So here we said there is a left limit. What is left limit? Left limit. When you take limit here, x close to c from the left, I write minus here, means something close to c but before c. Then what happened for your f of x close to what? Close to what exactly? What is the number here close? Your f of x close is not equal, but it's close. That's called left limit. And there is something called right limit. That is when you have x close to c, limit x close to c from the right. I write plus here. Plus means it's from the right, means after c. So after c. So what happened for your f of x close to what? Your f of x close to specific numbers. For example, again, if you have here 1, for example, when you take c equal 1, if I come from the right here, from these directions, x close to 1 from the right, then you could take, some people say, I'm going to come from the right here, maybe 1.001. Some people say, I'm going to take x equal 1.0001 and so on. It's okay, you take it anything close to 1 from the right, which means after 1. So when I say here x close to 1 from the right, that is from the right here, means after 1. After this number, which is after here 1, right? So it will be after 1, or sometimes, as you can see, because it's 1.001 or 1.0001, it's after 1, so it's very clear x greater than 1. So here, when I take right limit, x greater than 1, but it's very close to 1. And here left limit, when I say x take before 1, so in this case x less than 1, because I take 0.999 or 0.9, 0.39, 0.49, it's less than 1. So because of that, we call it left limit, right? Left limit. And here the other one, I have right limit when I take it from the right. So here I'm going to write a remark. What is the remark before I give you example here? What is the remark? The first remark here is if the left limit equal to the right limit, if they are equal, the right limit, then you tell me here, then the limit exists. The limit exists, right? Limit exists. So for example, if your left limit x close to c from the left, your f of x equals, say, L. What is L here? That is our left limit, right? Then limit x close to c from the right, your f of x equals, say, R. What is L? A number. So when x close to c from the left, before c, x very close to c, but from before c, then you get the number L, which means your f close to L. When x close to c from the right, your f close to another number, call it R. If it turn out your L equal R, if your L equal R, then the limit, what is the limit here? Your x close to c, that is either from left or right, your f of x, it will be either L or R because they are the same. So when x close to c, either from the left or from the right, equal the same number, which is our case. That is case number 1. I'm going to give you example for each case. Case number 2, if it turn out left limit or right limit does not exist. If the left limit or the right limit does not exist, then you quit. Then the limit itself does not exist. The limit does not exist. All right, the limit of your f does not exist, because if one of the left limit or the right limit does not exist, then the limit itself does not exist. Okay, so here we have what happened if the left limit, case number 3, if the left limit does not equal to the right limit, What I mean here is when you take limit x close to c from the left for f of x, you will get here L, which is not equal limit x close to c from the right for your f of x. If they are not the same, then you quit. Then your limit itself, what do you mean limit here? Limit means limit x close to c, your f of x, that is on, does not exist. If they are not equal, then does not exist, just does not exist. All right, so that is the summary of our goal today. Maybe we'll give some example here one by one in order to show what I have. So let us give this rule here. Example number one here. What is the example here? Try to find limit, right? That's example number 1. You have when x is close to 0 for f of x, where f of x equal x square. F of x equal x square. I need to get the limit when x is close to 0 for f of x. What is it? F of x equal x square. So here I could write it like this: limit x close to 0 for x squared. That is your f of x. That is my f of x. What is when x close to 0? What is x squared? Close to what? So here, note something here, guys. So that is, you could write it the question like this, or sometimes we write here, find when x close to 0, your f of x squared close to what? Close to, I'm just writing the answer here, just close to, try to find the number here, try to find that is your f of x, close to what? So that is, you could write the question like this, or you can write it, combine it, write it like this. All right, when x is close to 0, your f of x close to what? So in order to handle this here, when I say x close to 0, I haven't said, or I haven't informed you here as if x close to 0 from the left or x close to 0 from the right. So you have to consider when it had happened for x close to 0 from the left and from the right. So here I have to consider left limit x close to 0 from the left, right? So where is 0, guys? Here, oh, 0 here. 0 here. So I have to come close to 0 from the left from here. So which means before 0, right? Before 0. So for example, here take negative 0.0001. right? Negative 0.001, and then I have to figure out the number that I have to get here. So what is your f of x here, guys? So I need to know what is your f of x. Your f of x equal x squared. So now what is the value of f at this number here? That is the left limit, right? Negative 0.0001. So it will be negative 0.0001 negative 0.001 square. If I use technology for this, somebody can tell me here, guys, what is the number here I have? I don't have technology here. Maybe I open them. It will be something close to 0. You will see that is maybe, if I recall that in the class, negative 1, 10 to the power negative 8, 10 to the power. What is that? That is something very, very close to 0. Something very, very close to is not 0, but it's almost 0. It's almost 0. So what I have done here is limit x close to 0 from the left. From the left, look what you have from the left. Your f of x. What is your f of x? Limit x close to 0 from the left. X squared. It turned out almost 0. Almost 0. See here, when x is close to 0 from the left, your x squared close to 0, but is not equal 0, but close. That is what you have in here, close to 0. So when x is close to 0 from the left, it turns out your x squared does not equal 0, but close to 0 from close to 0. Okay, so I have to repeat the same story from the right. From the right limit, I have to get the left limit and the right limit. So that is our left limit. Our left limit, when I took x close to 0 from the left, your f of x equal x squared. So when I take x close to 0 from the right, so where is 0 here? All right, so I take something close to 0 from the right here, maybe, so which is 0.0001. So if I take x plus 0.001 like this, then what you have, your f of x. Your f of x equal 1. Your f of x equal x squared. So here you have your f at 0.0001. It will be 0.0001 square, which is, again, you will get something, the same number that you have up, the same number here, because here, look what you have negative sign, but it's square. Negative square, you get negative square, which is positive, and whatever you have here, similar to here. So here positive, but there negative, but you have negative square, which is positive, and here positive, so you will get the same number. So here the right limit, guys, just write it, the right limit, which is limit x close to 0 from the right. For f of x, you will have almost, which is limit x, that is limit here, lim stand for the limit, x close to 0 from the right, x squared, you get almost 0. This one here almost 0, but does not equal 0, but close to 0. So now, as you can see, your left limit, right, left limit equal to the right limit, both of them here close to 0, both of them is close to 0, then our limit x close to 0 exists, because the left, look what you have, the remark I wrote, number 1 here, I said if the left limit equal to the right limit here, left limit equal to the right limit, then the limit exists. So what I did, instead of C, you have 0 from the left and 0 from the right, then both of them R and L, both of them, they are 0. So here the limit exists and equal to 0. So I should write limit of x squared. When you have here 0, you get 0, right? You get 0. Does that make sense here, guys? Yes, it makes sense here. So x closed. So that is this technique here. We call it numerically, guys. Numerically. So what we have done, we call it numerical way. All right. So let me give you another example here. Example number 2 here. If I give you f of x equal square root of x. Square root of x. Well, what is the question here? I need to find the limit when x is close to 0 for square root of x. What is your f of x here? This one. I note something here. Whenever you have square root of x, you cannot have a square root of negative number. If you have a square root of -1 or negative any numbers, as soon as here you have negative number, then what you have, you will have error. You have error because this number here is not in the domain. So the error here means it's undefined. Undefined means the input, which is the value x here, it's not in the domain. So because of that, we call it error. So now when I take x close to 0 from the left, take for example one like -0.001, -0.001. What is your f of x? Your f of x equal square root of x. So if I find out what is f at -0.0001, you will see square root of negative number. You can use technology here. You have error. Error means your left limit does not exist because this one it's undefined. If I use technology, I shouldn't have any complaint. If you have a complaint, means you have error, means this number is not in the domain, your f undefined. Because of that, your left limit does not exist. Here, the left limit does not exist. All right, does not exist. Here, what is the left limit? Here is your left limit, x close to 0. From the left, you square root of x. So here you have negative. Here, look what you have. Here you have, that's from, let's call it left limit, that is undefined and does not exist. Then it's enough. If you look to the remark that I wrote in number 2 here. Number 2, if the left limit or the right limit does not exist, then the limit itself does not exist. The limit itself does not exist. We require your left limit and the right limit must exist and must be equal. So here your left limit does not exist, then the limit itself when x is close to 0, either from the right or from the left, for error f of x, which is limit x is close to 0 from the left, and from the right, does not exist. All right, does not exist. All right, guys. So that is one example here where I show you the left limit is not equal to the right limit. Okay, so that is one of the example here. I think I gave it to you. They have another example here. Maybe I go for the other example. So in the class here, I give this example, which is f of x equal to, maybe I just write the example here. You have square root of x minus 1, square root of x minus 1 as x close to 1. So as here, when I say as x close to 1, sometimes you write here limit x close to 1 for square root of x minus 1. That is, I need to find this. I need to find this one. So when x is close to 1, square root of x minus 1 equal what? Here is the hint, guys. Always, whenever you have a square root of something, it's very good to check what is the domain of square root of x. What is, if I give you this function here, guys, what is the domain of this one? And just let me show you. When this function here does not exist or undefined, or when you have error, if it turn out x minus 1 less than 0, because we cannot have a square root of negative number, right? We cannot have a square root of negative number. So x minus 1 less than 0 means here your x less than 1. So when I say x less than 1, so your x cannot be less than 1. Otherwise, what happened for this one? You will have a square root of negative number, which is undefined, or you have error when I use technology, right? So which means what? Which means limit x close to 1. If I take x close, where is 1 here or 1 here? Right, I am coming from the left, so x close to 1 from the left. I take a number close to, which is 0.999. Something close, so x close to 1 from the left, right? Say take x equal 0.999. So your f of x here is square root of 1, x minus 1, which is square root of, what is your x? 0.999 minus 1. If I use technology here, you will have error. Error means it's undefined, which means your left limit, when x is close to 1 from the left, x minus 1 here, it's undefined. Undefined means does not exist. Your left limit does not exist, right? Does not exist, and this conclude from here your limit itself, the limit itself, x close to 1 for x minus 1 also does not exist because your left limit does not exist. One of the limit, if the left limit or the right limit does not exist, then your entire limit does not exist. And here I want for you to show you, I mentioned when x is close to 1 from the left, x close to 1 from the left means I'm taking something close to 1 before 1. Come from the left here before 1, prior 1, right? So which means your x, when come x close to 1 from the left, means your x less than 1. Your x less than 1. So when you have x less than 1, because I'm coming from the left, with the meaning of x close to 1 from the left, it means x less than 1 means your x minus 1 less than 0. Means if I take 1 to the left, you have x minus 1 less than 0, means square root of x minus 1. Here x minus 1 is what? Less than 0. So square root of any negative number, whatever under square root is negative, means it's undefined, or you have error. You have error, right? So there is, I give you two examples here. For when the left limit does not exist, then the entire limit here does not exist. Now I have to give you another example here. What is the example I have to give you? Limit x squared minus 1 over x minus 1. And here I need to get the limit when x is close to 1. I need to find this x squared minus 1 over x minus 1, right? So the way that I give you about left limit and right limit, this technique is called numerically. Find the limit numerically. Numerically means you have to use come from the left and come from the right to the left. So now what happens if you assume this problem here is replace x by 1? If some people replace x by 1, you get 1 squared minus 1 over 1 minus 1. So what did you get here? Oh, you get 0 over 0. So 0 over 0, guys, is not 1. 0 over 0, we call it undetermined quantity. Undetermined quantity here in mathematics is not 1. Undetermined quantity, which means you have to do something. You have to simplify as much as you can before you take the limit. You cannot really take the limit right away. You're in a rush here, so you have to simplify this before I do that. So I'm going to do what I give you up here, how to find the limit numerically. Here I'm going to do it algebraically. What is algebraically here? Algebraically means I have to simplify that as much as I can, then I take the limit. So here, what is algebraically? So let me give you a hint, guys. When I took the limit, you have 0 over 0, right? So I have to figure out what is really cause 0 over 0. What is the problem? Why? From where I have 0 over 0. Let me show you. Limit x close to 1. I can factor this one as x minus 1. And then I can multiply that by x plus 1. The whole thing divided by x minus 1. Now, if I take the limit, if I replace x by 1 here, if I replace x by 1, what did you get? 1 minus 1, 1 minus 1. And here, 1 plus 1. And here, you have 1 minus 1. So what do you have here? What I have here is 0 multiplied by 2 divided by 0. So this term, that is the one you have 0, and this term, that is the one you have 0. Here you have 2. So what is caused problem here? X minus 1. So x minus 1 here, I should really cancel before I take the limit. I should factor out this, cancel those. Then what do you have? Limit x close to 1. And here what do you have? X plus 1. If I replace x by 1, what did you get? If I replace x by 1, you get 2. You get 2. So which means this fraction, when x is close to 1, your f of x here close to 2. Close to 2. Close to 2 means you get 2.001, you get 1.999, something close to 2. It could be 1.999, it's close to 2, or 2.0001, also close to 2. But here we write it 2 here, means when x is close to 1, the function here is given close to 2. That is called algebraically. So let me give you a hint here, because some people maybe forget how to factor. It's not easy always a factor like this. Sometimes you could have, you need really to know how to factor. Let me give you a hint. What is the hint here? How did I figure out x minus 1 here, x minus 1 here? What is given here? They tell you, you are done here, x is close to 1. So what happens if I take 1 to the left? What happens if I take 1 to the left? It will be x minus 1. If I take 1 to the left, x minus 1 close to what? It will be close to 0. When x is close to 1, x minus 1, I replace x by 1, you get close to 0, right? Will be close to 0. So because of that, that is a term that causes problem, x minus 1. That is a term that is give here when you have 0 over 0, that is come from x minus 1. So now when I have these kind of problems, then I can factor out right away. For example, here, the problem here is x minus close to 1, right? Your x close to 1, x close to 1, you have x squared minus 1 over x minus 1. Because I figured out here from there, when I took the limit, I got 0 over 0, means this one, it will be x minus 1 close to 0. X minus 1, I take 1 to the left, it become x minus 1 close to 0. Then this one, it will be x minus 1. I must get x minus 1 up, and I must get x minus 1 down. Even before I know how to factor this, I have to keep in mind, because this term 0 over 0, I must get x minus 1 here, I must get x minus 1 there, so that I can cancel them. Then here I look to this term, oh, x minus 1, which means if I factor this, must have x plus 1. So I can cancel. So I have x plus 1 that I did here. Then you get, take 2, you get here, you get 2. I want for you to practice here, guys. Do it numerically for me. You have to do that numerically for me. I leave that as exercise, but you know that the result here you are going to get here what? You are going to get 2. So most probably you have to do when x is close to 1, you have to take limit left from the left, which is x close to 1 from the left. You take x equals say 0.999, all right? And then what is your f of x? Your f of x equal x squared minus 1 over x minus 1, right? And then you go ahead and replace your f at 0.999, so it will be 0.999 square. I'm just replace x by 0.999 minus 1 over 0.999 minus 1, and then you can use technology here. You will get something close to 2. I don't have my technology handy here, but you could maybe you get 1.999, something like this. But what you really care, that is called left limit. Your left limit here, x close to 1 from the left, x squared minus 1 over x minus 1. The number here, just it will be almost 2. You'll see that it might be 1.998 or something like this. You use technology, you get something close to 2. That is called left limit. And what is the right limit? The right limit here, I am going to take right limit. You take x close to, okay, right? So here, oh, I see. Just the one here is moving here, so I should maybe I take it up. All right, so here I have to repeat that for the right limit. Okay, I think that's one here. All right, so right limit here, guys, you have to repeat x close to 1 from the right. So for example, here is 1, so I have to come from the right, so you get 1.001. right? You could have 30 even. It's okay. It's good to get something very close to 1. So 1.001. So your f of x, which is x squared minus 1 over x minus 1, I could replace that. It will be f at 1.0001, which is 1.0001 square minus 1, right? The whole thing divided by 1.0001 minus 1. You have to use technology for this. You get again something close to 2. It will be 2.001 or something. It's something close to 2. I don't have my technology here. You can do that. Make sure you get something close to 2, right? So that is what I really care. So here, what do you have? Your right limit here. For x squared minus 1 over x minus 1, you get almost 2. So the left limit equal to the right limit, then the limit itself equal 2. The limit itself equal 2. Does that make sense here, guys? All right, so here, I think I will stop here. And I think today here, I will continue for the limit. I'm going to give you more example here, how to do it algebraically, how to do it numerically. and that is our goal from today. Thank you. I will stop here and I will continue next class by giving more example about algebraically, numerically, and some property of the limit. All right.